Alright, this is the elimination method, and we've already talked about graphing and substitution for solving systems. Remember, graphing, we just graph two lines, find where they intersect for our solution. For substitution, we would solve for a variable and substitute in so that we could get it down to one variable at a time. Today is elimination. It sounds exactly like what we're going to do. We are going to eliminate a variable. So the first thing says to line up your like terms. So notice I have them lined up, my x's line up, my y's line up, my constants line up. Okay? Next thing is determine which variable to eliminate. You want to look for either opposite coefficients or the same coefficients. So what that means is look at the number. It doesn't matter whether they're both positive or one's positive and one's negative, but you're looking for the same number. So here I'm seeing in this first problem that I want it to be these two. Okay? If they are opposites, it's telling us we are going to add, because you're trying to cancel them out. And so to cancel them out, you would add them. I wouldn't subtract them, because a negative 10 minus 10 is a negative 20. That wouldn't cancel. So the next thing is add straight down, and one variable should be eliminated. So I'm going to add here, negative 8x plus 4x is negative 4x. Negative 10y plus 10y is 0. 28 minus 24 is 4. So I would solve then for the resulting equation. So divide by 4 on both sides. X is equal to negative 1. Substitute the answer into either of the original equations. That original word is going to be important later. Okay, so I'm going to substitute it back in. It doesn't matter which one. I tend to use the one that has more positives, so I'm going to do it for the second one. So I'm going to plug it in then for 4 times negative 1 plus 10y is equal to negative 24. Make sure you plug it into the correct variable. So if you're highlighting the parts, you should be plugging into the one that's not highlighted. Okay? So that's negative 4 plus 10y is equal to negative 24. So I add 4 to both sides. That gets me 10y is equal to negative 20. To solve, I divide by 10 on both sides, and y is equal to negative 2. So I put my answer together, and I know that my solution is at negative 1, negative 2 on that one. And I could always plug those back in and make sure it works. So it would be like negative 8 times negative 1 minus 10 times negative 2, and when I hit equals, it should be 28 in my calculator. Okay? The next one, so I'm going to skip. This one is very similar to this one. If you're watching the video because you were absent, you might want to try this problem and then go look at the answer key of the notes on Google Classroom, and you can double check and see if you did that correctly. This next one, again, line up the like terms, so my x's are on top of each other, my y's, my constants. Then determine which variable we're going to eliminate. I see that both of my x's have a 2 with it, so this time I'm going to eliminate my x's. Now, if I would try to add those together, 2x plus 2x would make 4x. That wouldn't eliminate it for me, so I need to do the opposite, okay? You're going to think of it as kind of like you're adding the opposite thing. Well, if I make this the opposite, then this also has to be the opposite, then this also has to be the opposite if they come in. Okay, so see how I changed each sign to the opposite. The positive became a negative, negative became positive, positive became negative. You have to do that for the whole thing. Notice, I did not do it for the top. Whichever one I was changing the sign for on the first term, I needed to change the sign for each of those in that row. Okay? Now, 2x minus 2x is 0. Y plus 2y is 3y. And 1 minus 4 is a negative 3. Okay? I solve. Y is negative 1. I plug that back in. Now, plug it back into the original problem. So that would be 2x minus 2y equals 4, or the top one. I tend to go with the one that I didn't do anything to, so I'm not trying to play and say, okay, was this positive? Was it negative? Did I make it this way? Okay, so put it back into the top one. So that'd be 2x plus y was negative 1 equals 1. Now, since I'm adding a negative, the opposite would be adding a positive. So I have 2x is equal to 2, divide by 2 on both sides, and x is equal to 1. So my answer on this one, make sure you put them in the correct order. X is 1, y is negative 1 for my solution. Again, this one is just like the problem we just did. So if you want to try that and then check it with the notes on Google Classroom, that would be great. Sometimes you can't find numbers that match up really easily. Like here we know we would have done the y's because they both had 2's. Here we would have done the x's because they both have 7's. This one I don't have any numbers that match up. There's no double 4 or double 3 or anything like that. So instead, you want to see what can I do to one of these equations to get to another number easily. Well, I don't know off the top of my head what I could multiply 3 by to get 8, but I do know what I could multiply a coefficient of 1 to get 4. So I'm going to multiply this first equation by 4. Notice, I'm not doing negative 4, and the reason for that is because I want them to be opposite signs, because then I can just add them together. Remember, if they're the same signs, these were both positive, I had to then flip all of the signs, and I don't want to take the time to do that afterwards. So I'm going to make sure the signs are opposite when I multiply. So since this one was negative, I want this one to be positive. So you have to make sure that you go to each part inside of there, kind of like you distribute to all of it. But when we distribute, we always said we didn't go across an equal sign. The way I want you to think about it is I'm taking this side and multiplying by 4. So what you do to one side of an equation, you have to do to the other side of the equation. Okay, so it's not really that it's distributive property. You can just kind of think of it that way. It's really the division property of equality, saying what I do to one side, I do to the other side. Okay, so that becomes 4x plus 12y equals 28. Now that I have this new one written out, I write the old one from the second one right below. Don't change anything. And now I can combine my like terms. Or, I'm sorry, just add straight down. So those cancel out. 12 minus 8 is a positive 4y. 28 minus 20 is 8. Oop. Divide by 4 on both sides, and I get y is equal to 2. So I'm going to take that and plug it back in. My top equation was the easiest one. Make sure you know, go back to the original, not to the new one. So I'm going to plug that back in. So that's x plus 3 times 2 is equal to 7. So x plus 6 is equal to 7. Subtract 6 on both sides, and x is equal to 1. So that means my point here is 1, 2. On the next one, when I look, remember I'm trying to go from one equation to the other easily. I don't know what I could multiply 4 by to get 6 off the top of my head, but I know what I could multiply 2 by to get 4. So I'm going to multiply this one. Remember, if I multiply by 2, that would give me 4x. I want it to be the opposite of this one, so I'm going to make this a negative that I'm multiplying everything by. So the first equation stayed the same, 4x plus 6y equals 22. The second equation, negative 2 times 2x is negative 4x. Negative 2 times negative 4y is positive 8y. And negative 2 times negative 10 is a positive 20. Now, those cancel out. 6y plus 8y is 14y. 22 plus 20 is 42. I divide both sides by 14, and y is equal to 3. So I plug that back in. I'll plug it back into the top one. So 4 times x plus 6 times 3 is equal to 22. That's 4x plus 18 is 22. I subtract 18 on both sides. 4x is equal to 4. So I know x is 1. That means my answer is 1, 3. Okay? Sometimes you can't easily find that if I multiply one equation, I can get a number in the other one. Because here I don't know 5 times what gives me 7, or 4 times 3 gives me 6. So in that case, what you're going to do is you're going to kind of flip-flop the variables. So in this first one, if I'm going by the x's, I'm going to switch the coefficients. So this first one I would multiply by 6, and the second one I would multiply by 4. That way these will come out to be the same numbers. Now, right now, a positive times a positive would give me a positive 24, and a positive times a positive would give me a positive 24. I want them to be opposite sides. So I'm going to make one of them the opposite. So I'm just going to make it this one. It doesn't matter which one you choose. Now I'm going to go through and finish this. 6 times 5y is 30y. 6 times 6 is 36. Negative 4 times 6x, that's a negative 24x. Negative 4 times negative 7, that's a positive 28y. Negative 4 times negative 20, that's a positive 80. From there, I combine my like terms. So I know these will drop out. I'm eliminating those. And my 30 plus 28, that gives me 58y, is equal to 116. When I divide both sides by 58, I get y is 2. Then I can plug it back in. You can choose which one you want to plug it back into. So I'm just going to use the top since they're all positive. That's 4x plus 5 times 2 equals 6. So 4x plus 10 equals 6. Subtract my 10 on both sides. That's 4x is equal to negative 4. When I divide by my coefficient, x is negative 1. So my solution here is negative 1, 2. Now, if you notice, it's the same problem right here, and the reason is because I want to show you that if we wouldn't have tried to eliminate our x's and instead of did our y's, we would still come up with the same problem, or with the same answer. So this time I'm going to flip-flop my y's around, so this will be a 7, and this will be a 5. Now, some people think, oh, it's a negative 7, so I'm going to take my negative out there. Well, if you think it through, right now, a positive times a positive would give me a positive y, and a positive times a negative would give me a negative y. That's going to give me opposites. That's what I want to happen. Okay? So kind of a trick to think about is whichever ones you're trying to eliminate, look at it and see, right now they are opposites. So out here I want them to be the same. On these, here they were the same, so out here I wanted them to be opposites. Okay? So 7 times 4x, that's 28x. 7 times 5y, that's 35y. 7 times 6, that's 42. 5 times 6x, that's 30x. 5 times negative 7y, that's negative 35y. and 5 times negative 20, that's negative 100. This time around, it's my y's that cancel out. So 28 plus 30 gives me 58x equals, and 42 minus 100 gives me negative 58. Divide by 58 on both sides, and I get x is negative 1. I plug that back in. Again, it can be either one. I'm going to pick the top one since they're both positive, or since all of the numbers are positive. So that's 4 times negative 1 plus 5y is equal to 6. So negative 4 plus 5y is equal to 6. I add my constant on both sides. 4y is 10. So y is equal to 2. My answer on this one would be negative 1, 2. Okay? The next two examples are just like those, where you're going to have to multiply by two different numbers. Where here I only had to multiply one of the equations. This I'm going to have to multiply both of the equations. So again, if you want to try that on your own and then check with the answer key on Google Classroom, that way you know what you're doing on those. The last set. Here's another one where we have to multiply both of them. I'm going to go for my y's just because these are smaller numbers and I like to work with smaller numbers. So the first one I'm going to do by 5. The second one I'm going to do by 4. So, since here they're opposites, here I'm going to keep them the same because that'll give me a positive 20y, this will give me a negative 20y, and they easily cancel each other out. 5 times 8x is 40x. 5 times 4y is 20y. 5 times 20 is 100. 4 times negative 10x is negative 40x. 4 times negative 5y is negative 20y. And 4 times negative 25 is negative 100. Hopefully you are already noticing something here. 40x minus 40x is 0. 20x minus 20y is 0. 100 minus 100 is 0. So technically they are all canceling out. That means this side is left with 0, this side is left with 0, and 0 is equal to 0. That means it's infinitely many solutions. Remember, on a graph, that would be that they have the exact same slope, the exact same y-intercept, they are the exact same line. Okay? On the next one, I'm going to multiply the top one by 4 and the bottom one by 3. Again, since these two, I'm trying to eliminate my y's here. Since this is a positive and this is a negative, out here they can be the same. So 4 times negative 6x is negative 24x. 4 times 3y is 12y. 4 times 6 is 24. 3 times 8x is 24x. 3 times negative 4y is negative 12y. 3 times negative 12 is negative 36. I notice that these are going to cancel. Negative 24x and 24x. Also 12y and negative 12y. But this time this side doesn't cancel out. So that's 0, and this is 0, that making the left side 0. The other side, 24 minus 36 is a negative 12. Those are not equal to each other. When they are not equal to each other, that means there's no solution. Remember, on a graph, that means that their slope would be the same. They have different intercepts, so they are actually parallel lines. They're never intersecting, so it's no solution. Okay? Let me know if you have any questions on this, and I'd love to help.